Hello, this video is on lesson 9-1 and we will be talking about how to solve quadratic equations by taking the square root. This lesson begins on page 137. Now, before we begin this lesson, it's very important to point out something that we call rationalizing the denominator. Now, what is rationalizing the denominator? Well, that simply means that in mathematics, whenever you have an answer, and if the answer contains a square root in the denominator, which is what we have here, we want to find a way to get rid of the square root in the denominator, hence rationalizing the denominator. Now, why do we want to do that? Well, that's just basically a formality in mathematics. We don't want a square root in the denominator, so we have to find a way to get rid of it. Now, so that is the whole point of this. So how do I rationalize the denominator if my answer comes out as the square root of 16 over the square root of 3? The first thing you want to keep an eye out is for perfect squares. Remember, perfect squares are numbers when you take the square root of, it comes out as a whole number. So square root of 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So take a look at that. Here, we know that the square root of 16 is going to be 4, and so I can rewrite this as 4 over the square root of 3. Now, my denominator still has a square root, so I still have to take care of this by rationalizing the denominator, and this is what I need to do. What I need to do is basically multiply the denominator by the square root itself. And so here, I'm going to multiply the bottom by the square root of 3, and whatever I do to the bottom, I have to multiply to the top. And notice when you multiply the square root of 3 times the square root of 3, well, the answer is 3. And what I have on top is basically 4 times the square root of 3. Here is my final answer. I don't have a square root in the denominator anymore. I have a whole number, and this is what we want to have in the end. Notice the square root of 3 is not a perfect square, so that's why we leave it just like that. Alright, let's take a look at this example. Now remember, square root of 16 is a perfect square, so when I rewrite this, we're going to have 4 in the denominator, and then 3 is not a perfect square, so we just leave it the way it is. And take a look at this. Have we rationalized the denominator? Well, we took the square root of 16 because it's a perfect square, and it turns out that we don't have a square root in the denominator anymore. And so always keep an eye out for perfect squares. A common mistake that I see students make is that they don't realize that 16 is a perfect square, and so they end up multiplying by the square root of 16, both top and bottom, and then they multiply the square root of 3 times the square root of 16, which basically you're multiplying the numbers inside the square root. It turns out to be the square root of 48, and then they have 16. Now, this is not wrong, it's still correct, but you want to get it into the most simplest form, and this would be the more simplified form right here. This you can simplify even further, which will eventually lead you to this. How can you simplify that further? Well, notice that the square root of 48 is square root of 3 times square root of 16. Well, what's the square root of 16? Well, that's going to be 4. So you basically have square root of 3 times 4 over 16, and then 4 divided by 16. Well, that simplifies to 1 over 4, and you end up with the answer that we started with. But why give yourself all this extra work when you can just realize that you have the square root of 16 and you can have this final answer right away? Alright, so that is just a small explanation of what rationalizing the denominator is. Alright, so let's start with an example of how do we solve square roots. Let's take a look at this example. Now here what we're going to do is basically we're going to use reverse PEMDAS where addition and subtraction is my first level, division and multiplication is my second, exponents are my third, and finally parentheses is my last level. So using reverse PEMDAS, can you identify any addition or subtraction? Here we are subtracting 23, and so we want to do the inverse, the opposite of subtracting 23, which is to add 23 to both sides. And so what we have is 5x squared is equal to 23. Okay. We don't have any more addition or subtraction, so cross that out. Division and multiplication is my next level. As you can see, we're multiplying by 5. That's the operation between the 5 and the x squared. So the inverse is to divide by 5. Whatever you do to one side, you have to do to the other. Alright. 5 over 5 basically becomes 1, so we just have x squared. And 23 divided by 5, well, we'll just leave it just like this. We can't divide 23 by 5 evenly, so we just leave it as a fraction. And it turns out that we don't have any multiplication or division. Let's go on to our next level, where we have exponents. Here we do have an exponent of 2. So we're squaring x. What is the inverse, the opposite of squaring x? Well, that is going to be to take the square root. Whatever you do to one side, you must do to the other. And so what we have is we have square root of x squared is x. And here, since we're taking the square root of a fraction, what we can do is separate the single square root into two different square roots, where we have the square root of the numerator and the square root of the denominator, plus or minus. So this is a rule that we have to remember. Whenever you take the square root of a fraction, it basically separates into two square roots, where the numerator has a square root and the denominator has a square root. Now notice here, this would be, we finally solved for x. X is isolated, and it equals to plus or minus square root of 23 divided by square root of 5. But remember that rule, we don't want a square root in the denominator. So what we want to do is multiply by the square root itself. Let me just make this clear. This is square root of 5. So what we need to do is multiply by the square root that we have here, both top and bottom. And let's go ahead and multiply them out. So x is equal to plus or minus. We already know that square root of 5 times square root of 5 is just basically 5 without the square root. And when we multiply the square root of 23 times the square root of 5, we basically multiply the numbers out, and we get that x is equal to the square root of 115. That is my final answer. You always want to keep an eye out if you can simplify this any further. 115 seems like a pretty large number that you might be able to simplify it, but it turns out that since we had the factors of 23, it is not a perfect square. You can't break that down any further, and then you have square root of 5. Well, that's not a perfect square, so we can't simplify it any further. This would be my final answer. Again, what we did here, we used reverse PEMDAS in order to solve for x, and once we solved for x, we wanted to rationalize the denominator. Basically, we don't have a square root in the denominator anymore. Alright. So we do have some more examples. Let's go ahead and do C. So what we want to do here is again follow reverse PEMDAS, and so there we go. Our first level is addition or subtraction. Here we're subtracting 16. The inverse is to add 16 to both sides, and so we get 5x squared is equal to positive 16. Now we want to go ahead and divide both sides by 5. So what we get is x squared is equal to 16 divided by 5. Now our next level is exponents. Since we're squaring, we want to do the opposite of squaring, which is to take the square root. Now remember, the square root of x squared basically becomes x. What we have here, we have the square root of a fraction. We can separate that into two square roots. Square root of 16 over the square root of 5. And again, here's what you always want to keep an eye out for. Do we have any perfect squares here? Yes, we do. We have the square root of 16. And the square root of 16 is basically 4. So we have plus or minus 4 over the square root of 5. Notice that we still have a square root in the denominator, so we need to rationalize the denominator by multiplying both top and bottom by the square root that we have here. And so we get 4 times the square root of 5 over 5, plus or minus. There we go. That is the final answer. Alright. Now, I do want to have you do some more examples with rationalizing the denominator. Let's just do 3 really quick, where we have 40 times square root of 10 over square root of 2. Again, the way we rationalize the denominator is basically multiply both top and bottom by the square root that is in the denominator. So we multiply the square root of 2, both top and bottom. And here we have 40 times the square root of 10 times the square root of 2. You can multiply the numbers inside the square roots, so that's going to be square root of 20 over the square root of, actually, over 2. Now notice, we have 40 divided by 2, and so this means that we can divide 40 divided by 2, it's 20, and so our final answer is plus or minus 20 times the square root of 20. That's my final answer. Now I do want to go over an example where example B. Let's take a look at this. Alright. So what we want to do here is, again, continue using reverse PEMDAS. Looking at our first level, we have addition or subtraction. Here we're subtracting by 5, and here notice that inside the parentheses we're subtracting by 3, but since parentheses is in my last level, I don't want to start with that. So the opposite of subtracting 5 is to add 5. So what we get is 2 times x minus 3 squared is equal to 5. Again, next level is division and multiplication. Since I'm multiplying by 2, the inverse is to divide by 2 on both sides. And so 2 over 2 is basically 1, so we just have 1 x minus 3 squared is equal to 5 over 2. We'll just leave it as a fraction. Now we move on to exponents. We're squaring the parentheses, so the opposite of squaring is to take the square root. Whatever you do to one side, you must do to the other. And so now, the square root and the squared basically just cancel each other out, and we have x minus 3 is equal to, again, since we have the square root of a fraction, we can take the square root of the top and the square root of the bottom. Next thing we want to do, now we still have the parentheses. So parentheses is my last level, and now we can, since we only have one operation inside the parentheses, we can just go ahead and take care of it. We're subtracting 3. What is the opposite of subtracting 3? Well, to add 3 to both sides. So x is equal to plus or minus square root of 5 over the square root of 2 plus 3. Now just one more thing, remember we do have a square root in the denominator. We want to take care of that, so we have to rationalize the denominator by multiplying by whatever we have here on both top and bottom. So x is equals to plus or minus, we can multiply the numbers inside the square roots here, so that's the square root of 5 times 2, which is 10, over 2 plus 3. Alright, there we go. Just one last thing. If you ever happen to have your answer, let's say for example, if you ever have your answer be something like this, 240 over 3, you might say, okay, well, I don't have a square root in the denominator anymore, so this would be it. This is my final answer. X equals plus or minus square root of 240 over 3. Which is, I do have a very good example that's very similar to this. It's going to be this one. Let's do this one real quick. So we have 5x squared minus 16 is equal to 0. No, this is not the example. Okay, let's just use this example here. Now, what you want to do here is you want to find the simplest form. Notice that 240 is a very large number. We can definitely simplify the square root of 240. Now, in order to simplify it, what you want to do is remember, what are your perfect squares? A perfect square is 1, 4, 9, 16, 25, and so on. Because when you take the square root of each of these numbers, they turn out to be whole numbers. So you want to be able to divide 240 by any of these numbers, starting with the smallest one. But in this case, every number has a factor of 1, so it's not going to help us much. But can we divide 240 by 4? So let's take 240 and see if we can divide it by 4. 240 divided by 4 is going to be 60. Now, 60 seems like a pretty large number. Can we divide it by 4 as well? Turns out that we can. 60 is composed of 4 times 15. And notice, these are going to be my factors. Now, I could have broken down 4 into 2 and 2, but I'm mainly interested in finding the perfect squares. these numbers right here. And here I have two perfect squares, and so the way I want to write my answer is plus or minus 240 is now basically 4 times 15 divided by 3. And notice that how many factors do we have here? We have 3 different factors, so that means each factor gets its own square root. So we basically have the square root of 4 times the square root of 4 times the square root of 15, all divided by 3. And since 4 is a perfect square, basically square root of 4 becomes 2. Again, square root of 4 becomes 2, and then 15 is not a perfect square, so it just stays as a square root of 15 divided by 3. And finally, my final answer is going to be 2 times 2, which is 4 times the square root of 15 over 3. This is my final answer. And so notice we started with this being equal to the square root of 240 divided by 3. This is the most simplest form that you want to leave your answer as. Alright, so this lesson has been on solving quadratic equations by taking the square root. Alright, thank you for watching.